So component method is something which we did in the last class only.
Mm-hmm.
And here, as you can see, so there is given the each problem and how the direction is mentioned. All right. So in the problem one, it shows two vectors. This is vector A, which is supposed to be 60. Now it shows the direction,
Mm-hmm.
and the direction is 20° north of east. This is how it should be written. Similarly, we have another vector B, which is supposed to be 40, and the angle is 10 degrees east of north. So basically, first of all, we have to understand that where do these vectors actually lies, like in which direction they are actually present. So in order to do so, we need to make them represent graphically first, and then only we can write it. So in order to do so, we need to understand that where these vectors actually lie in the plane.
Mm-hmm.
So suppose this is my direction axis, this is north, this is going to be south, this is going to be east, this is going to be west. Now, what does this 20° north of east means? So 20° north of east means that the vector 60 is making 20 degrees from east, something like that.
Oh.
So this angle is supposed to be 20 degrees. This is my 60 vector. Now this vector must have something like I would say. So I would assume this is 60 kilometers,
Yeah.
like that. Similarly, vector B is 10 degrees east of north. So 10 degrees east of north means that this vector is going to be 40 kilometers and it is making 10 degrees, like that. So we have to find the resultant of these two vectors. And how can we do so? Let's understand it. So first of all, we have to understand that all these two vectors must have component along x-axis as well as along y-axis. So if I choose the first vector as 60 kilometers and the angle is given as 20 degrees here. So this vector has one component along x-axis, which is supposed to be 60 cos 20. Similarly, we have another vector which is supposed to be along y, which can be written as 60 sine 20, like that. Similarly, if I draw another vector of 40, so how I am supposed to do this? Like that. This is 10 degrees and it is 40 kilometers. So again, it will have two components along x-axis as well as along y-axis. So along x-axis, it is going to be 40 sine 10, and along y-axis, it is going to be 40 cos 10. So just tell me one thing. Do you remember that how this cos and sine component came for each of the vectors?
Um. Yeah. Because cosine is adjacent over opposite. I mean hypotenuse. So
Yeah,
if,
and
if you,
we are doing that only here.
yeah, if you like think of it as a triangle kind of.
So how we are supposed to solve it further? We'll be adding the components along x-axis, and we can write that summation of x is going to be 60 cos 20 plus 40 sine 10. Now, in order to find the value of this cos and sine, we can simply use calculator. There is no issue on that. Similarly, along y, the summation along y can be written as 60 sine 20 plus 40 cos 10. So we can solve them and we will have the values of them. Now, the important part, the most important part is resultant, that how we are supposed to find the resultant. So remember the earlier relation, and that r square is something which can be written as a square plus b square plus 2ab cos, and here that cos should be 90 degree, because whenever we are going to add x and y axis, we will get two vectors, and these two vectors should be perpendicular to each other. So this will make cos 90. So r square can be written as a square plus b square. So a square is supposed to be this will give us a, and this will give us b. We'll simply substitute the values and we will get the answer. Let us solve it.
Right. So it'll always be cosine when basically the axis, the vector is in the angle it will always be cosine.
Yeah, this is what we have seen in the vector addition triangle law, like a square plus b square plus 2ab cos theta. So just review the first lecture once again, you will get the relation again. So that is what we have to use. So let us find the values. So here, when we put the values, so we'll get summation along x-axis is going to be, we will simply solve it. So 60 sine 20 degree is going to be 20 plus 5215. Again, I am using calculator to find these values, and you can use the same.
Okay.
Plus 39.39. So this will give us the value as 59.9 kilometers approximately. This is along x-axis. Similarly, we'll find the same along y-axis, and it is going to be 56.3816 plus, we will get it as 6.9459. When we put the values, so we'll get the summation along y-axis is going to be 63.3 kilometers. Now these values you can directly find using calculators, as the calculators is allowed to use during the examination also. So you can do that. Here, generally the values of sine and cos that should be used in the question should must lie between 0 degree and 360 degrees. So any of the values between them can be given here. So now we have to find the resultant, and resultant must have magnitude r, which is equals to a square plus b square. I can assume this as my a, I can assume this as my b. So resultant is going to be 59.9 square plus 63.3 square, whole under root. Once you solve this, you get the resultant is approximately to be 87.1 kilometers. So this is the resultant of these two vectors, which is given in the problem 1. Now, the next important part is we have to find the direction. And if you remember, we find the direction using angle. So how we are supposed to do the direction thing? Again, if you look at the diagram, if you look at this, so I found this as 59.9. So I will write 59.9 here, and along y-axis, I got approximately 63.3. So I would write here 63.3. Now, the resultant of these two vectors must lie between them. And how can we find this resultant's direction? By simply finding this angle theta. So how can we find this angle theta? Again, using trigonometry. So trigonometry gives us that this can be found using tan theta, and tan theta is going to be this 63.3 divided by 59.9. So it is going to be 63.3 divided by 59.9. So theta is going to be tan inverse 63.3 divided by 59.9. When you solve this, you'll get theta is approximately 46.6 degrees. So this is how we are supposed to find the direction as well. So this was the first problem that we can do and we can solve accordingly. Similarly, if it is in question B, it is C minus D. So we have given C vector, we have given D vector, and we can simply do the subtraction there. Let's do that one as well. So does this make sense that how we're going to do this?
Uh, yeah, yeah, it is.
All right, let's move to the second problem and it will be more sensible now.
Okay.
First of all, you need to write what it is given to you. And in problem 2, we have to find c minus d. So we have given two vectors. First is vector c and it is given as 80 kilometers at east of 30 degrees south. So this again east of 30 degrees south, we'll draw it. Then we have given d vector which is supposed to be 100 kilometers at 10 north 10 degrees of west. Now this is an important part. We have to find c minus d. So we actually have to write minus d here because
Oh,
when we are adding c and minus d, like how we can write this c minus d? Can I write this c minus d as c vector plus minus d vector?
yes.
So suppose if there were two vectors, this is c vector and this is d vector. So, but we have to find the resultant of c plus minus d vector. So how can we do so? So we will simply change the direction of d by rotating it by 180 degrees like that. So now it becomes minus d vector. So this minus d vector and this c vector is when added, the resultant will be in this particular direction like that. But this is just an explanation that how this subtraction is actually being done, but we cannot directly use it because we have given the direction of c as well as we have given the direction of d. So we can use that and then only we'll be able to do so. So when we are writing this d, we need to write what is minus d. So minus d is going to be approximately, or which we would say it is going to be 100 kilometers at, it is given north 10 degrees of west. So it would automatically become south 10 degrees of east when we change the direction. Like as you can see here, the d is completely reversed. So when it is reversed, so the direction will be completely changed. So this north 10 degrees of west will change to south 10 degrees of east. That is what we need to understand here. That is what this minus d signifies here.
Okay.
Without understanding this, we won't be able to find the resultant. Or if we did it, or if we actually subtract it, the answer is not going to be what it should be. So let's
All right.
draw this, and again we'll try to figure it out that how it should be written. So it is going to be like that. If I am writing c vector, it again must have two components. One component is along x-axis, another component is along y-axis. The component along x-axis should be written this way. So it is east of south, so I would probably draw this vector as per the directions only. Same thing, we'll draw the directions first. It is north, south, east, west. That says east 30 degrees of south. So east 30 degrees of south means the vector is lying this way and making 30 degrees with east. And it is approximately 80 kilometers, I assume. So this thing will have two components. One is along x-axis, one is along y-axis. X-axis component will be 80 cos 30. And the component along y-axis is going to be 80 sine 30. This is the most important part, how we actually resolve vector and where the vector actually lies. That is an important part. Similarly, if we draw the another vector that is minus d, it is south 10 degrees of east. So how it is supposed to be drawn? It is supposed to be drawn this way. That vector must lie along this line and this is going to be the angle that is 10 degrees. So this is vector minus d. I will write it as minus d. Now again, this vector has two component. One component is along y x-axis So x-axis along x-axis it should lies like that. So it should be 100 sine 10 degrees. Similarly, there is another component along y-axis, so it should be 100 cos 10 degrees. So if you actually say this, so when we are finding summation of x, so can I write it as it should be 80 cos 30
Yeah.
minus 100 sine 30 minus 100 sine 10. Now, why I have written minus sign in between them, mm, irrespective of this, that we are actually adding them because the direction. This vector is along negative x-axis, so we will write it as negative 100. This vector is along positive x-axis, so we will write it as positive 80 sine cos 30, 80 cos 30. So now we will solve it, and once we will solve it, we'll get the value of summation along x-axis. So it is approximately, uh, you have to figure it out that what it is going to be. So 80 cos 30 is approximately 69.28. Again, you can use calculator to do so directly. Just type 80 cos 30 and you get the value. Similarly, minus it is going to be 100 sine 30. So 100 sine 30 is approximately 17.36. Remember why I have chosen the negative sign and how we are actually using it depending upon the direction of vector only. Without you considering the direction, we won't be able to use it or we won't be able to find it. That is how it should be done and it should be solved. So when we add them, we get it is approximately 686.6 kilometers. Or I would say it should be negative of 100 and we are subtracting it. So now this is the catch here. So this negative negative will automatically become positive and this will give us 86.6 kilometers. This was minus d. So I would write minus 100 sine 10 in this direction and I will write minus 100 cos 10 in this direction. So ultimately it will be added up. So it will add it up to give sun net vector along x-axis as 86.6 kilometers. Similarly, we will find out along y-axis. Now just look at it and tell me. So if you can look at it here, so there are two vectors 80 sine 30 and another minus 100 cos 10. So just think of this and tell me what we are actually going to do here.
Um, this one you do 100 cos 10.
Yeah, 100 cos 10, negative of 100 cos 10. That is
Right,
important.
negative. And then plus
Plus,
um 100 sine 10 or minus 100 sine 10.
minus 80 sine 30. This is the vector.
Oh,
This is the first.
oh, I see, I see.
This is the second. It is going to be negative of 80 sine 30.
Okay.
Now, if you look at it here, both the vectors are in negative sign. Why? Because it is going along negative y-axis. So if it is along negative y-axis, so it will automatically give us negative vectors. That is what we need to understand. So if we solve it, if we write the values, so 100 cos 10, it is approximately 98.48 minus 80 sine 30. It is approximately 40. Once we solve it, we got EY is negative of 138 kilometers or 138.48 kilometers to be approx. So this will give us a value of the net vector along y-axis. This is how it should be done and it should be calculated. Again, resolving
Um,
vector as per the direction, that what makes it important. Then only we'll be able to solve it. Now we will follow the simple process. We'll find the resultant and then we'll find the direction. So for resultant, we'll have that same formula. That resultant is nothing but a square plus b square whole under root. because cos 90 is 0. We'll substitute the values here for a square as well as for b square, and we'll get the value as. So it is going to be 86.64.
But why were we comparing the 100 sine 10 and 80 cosine 30? Because
100 sine 10, 80 cosine 30. All right. See, whenever we are solving vectors, we are trying to find out vectors first along x-axis, because this is
yeah.
along x-axis, and then along y-axis.
Oh,
So we'll solve along x-axis, so it will give us summation of vectors along x-axis. Then we'll solve along y-axis. It will give us summation along y-axis. So this is how it should be done. So once we are doing this, so we get two vectors along. One is along x-axis, one is along y-axis. So we know that when we need to find out the resultant, we need to know the values of these two vectors, and we actually find the values of these two vectors like that. Once we got this, we'll simply square it and substitute the values of b vector as well, which is approximately negative of 138.48 whole square. So here, when you square it, then under root, take root of it, you'll get approximately 163 kilometers. So this is the resultant, or you
got
can
it.
say this is the magnitude of the resultant. Now we have to find the direction, and for direction, the process is again very simple. What you are going to do, you're going to find out tan theta. So tan theta is going to be summation along y-axis, summation along x-axis. So theta can be written as tan inverse. Summation along y-axis is nothing but 138.48. Summation along x-axis is nothing but 86.64. When we solve it, we'll get theta as 57.9 degrees. This is how we are supposed to solve this.
Wait, why is the 138 not negative?
Because whenever we are finding the direction, we are actually using the mod.
Oh, right,
So
right.
when we are using mod, it won't be taken as negative.
Okay,
This will only give us the magnitude, like the net magnitude is along this particular direction, and it should be this. So that's why.
got it.
Yeah. So after that, I would love to do fourth problem. Why? Because it is has that negative thing also, and it has that product also. Let's talk about it. Fourth problem. So according to the fourth problem, we have given two vectors, and we have to find 3b minus 2a. So what does it mean? Now we have to apply both the things which we did in the first two parts. Here, apart from that, we have to also do the product of vector b with 3 and product of vector a with 2. Then only we'll be able to do this. So let's first of all find 3b. What is 3b? So 3b vector is going to be 3 times the product of vector b, and vector b is given as what? It is given as 40 kilometers. So it is supposed to be 120 kilometers at east of 10 degrees north. So this is something we got, vector 3b. Now we'll find vector 2a. So 2a is going to be twice of vector a, and vector a is given as 60 degrees. So it is going to be 60 kilometers, I would say, not degrees.
Yeah.
So it will give us 120 kilometers at north 20 degrees of east. Now, as you can see here, it is negative. So I can write it as 3b plus negative of 2a.
Yes.
So what we actually need, what is 2a, negative of 2a. So negative of 2a is going to be 120 kilometers at. Now just think of the direction which is exactly opposite to 20 degrees north of east. Or you can say north 20 degrees of east.
It'd be
So,
south 20 degrees of west.
mm, correct.
Mhm.
You got it right. So now we got two vectors. Now we need to again draw the same diagram like this
Okay.
one. Along x and y axis, we'll figure it out what are the components of vectors lying, and then we'll simply add them. This is north, this is south, this is east, this is west. We'll draw the vectors first. So we have given 3b vector, which is supposed to be 120 kilometers east of 10 degrees north. So 120 kilometers east of 10 degrees north means the 120 degrees lies with like that. This is going to be 10 degrees, I would say.
Okay.
Not this one. That should be east of 10 degrees north means this. This is going to be the 10 degrees. So it is
So
120 kilometers.
you first consider when it's like east 10 degrees of north. So you first look at the east, and that's the part where that's the axis the vector will start, and then north is the side it like leans towards basically.
Yes, that is the important thing. Whenever it says it's east 10 degrees of north means you have to draw the angle from east,
Right.
right? And when it says north 20 degrees of east means you have to draw the angle from north. That is going to be
Okay.
the next vector. So this will have two components. We'll write its two components. One, it should be 120 degree cos 10, and another component is going to be 120 degree sine 10. That is the important part. Similarly, the another vector, it is 120 kilometers north, 20 degrees of east. So it must be drawn like that, and this angle is going to be 20 degrees, and it is given as again 120 kilometers. So this vector will again have two components. One is along x-axis, one is along y-axis. So for x-axis, it is going to be 120 sine 20, and for y-axis, it is going to be 120 cos 20. But we have to do one thing again. We have to like change the direction because it is not negative, it is positive. So when we change the direction, it will go like that. And this will become 20 degrees, and this will become negative of 2. So this will again have two components. We can change the direction of this. It will give us this direction, which is going to be negative 120 cos 20. Similarly, we have to change its direction as well. So it is going to be this negative 120 sine 20. Now, what are the two vectors that we actually have to resolve? First, along x-axis, going to be these two vectors. Second, along y-axis, which is going to be these two vectors. One is this, another is this. Let me
Okay.
draw the diagram again. I guess it becomes a little complicated. Let how it should not be drawn this way. Let me draw it again. So
Okay.
pretty simple. Two vectors, one lying in this direction, one lying in this direction, then one lying in this direction, one lying in this direction. Let us give us the values. So it is going to be 120 cos 10 degrees. It is going to be 120 sine 10 degrees. Similarly, along negative 2 vectors, you can say x component is going to be negative of 120 sine 20, and along negative y-axis, it is going to be negative of 120 cos 20. Now, I guess it makes it easier to understand. So summation of delta x is going to be 120 cos 10 minus 120 sine 20. We were actually adding these two vectors. So this is how it should be written. When we solve it, we'll get the value along x-axis is approximately 77.1 kilometers. Now just tell me one thing. Do you know how to solve this Exactly, using calculator, like what is 120 cos 10?
Yeah. You first just put in the cost 10, and whatever you get from that, you multiply 120.
Yeah, correct. Similarly, we'll find what is EY. So EY is going to be 120 sine 10 plus minus 120 cos 20. Remember the process. Process is important. If you understand the process, you can do it. Like whatever question is come to you, you can easily solve it. So 120 sine 10, it is approximately 20.83 minus 120 cos 20, it is approximately 11276. So when you solve it, you'll get EY as negative of 91.9 kilometers. So here we finally got the two values. EX, we'll consider it as A. We got EY, we'll consider it as B. Now, what is the process of finding the resultant? It will be the same as the earlier one. So it is going to be A square plus B square whole under root. So we are going to get it as R as A square plus B square. A is going to be this 77.1 whole square plus it is going to be negative of 91.9 whole square root. So resultant we can find or we'll get approximately it is 120 kilometers because as we know that the two vectors this and this has value 120 kilometers only. So resultant will automatically become equals to the magnitude that is 120 kilometers. So if this question came into multiple choice part, so we can directly click on whatever number option shows the similar vector 120 only. This is what resultant shows as well. Similarly, we'll find the direction also, and for direction we know we will use tan theta, and tan theta is something which is equals to summation along y by summation along x. So theta is going to be tan inverse. Summation along y is 91.1, 91.9, and along x is 77.1. So when we solve it, we'll get that theta is somewhat approximately 50 degrees. So this is how we are supposed to solve this.
Okay.
But another catch here. So this is my one vector making 10 degrees. This is my another vector making 20 degrees. So we know that the resultant of these two vectors must lie between them like that.
Yeah.
Now this 50 degree is the angle which is made by this resultant vector with x axis like that. So this is the 50 degrees. But whenever we are finding angle from x-axis, it should be drawn in anti-clockwise sense. So the angle must be given like that. So if it
Oh,
is 50 degree, if it is total angle is we know 360 degrees. So direction, the final direction should be given as 360 degrees minus 50 because angle is always considered in anti-clockwise sense, not or never in clockwise sense. That is the important thing here. So direction is going to be 310 degrees. This is what we need to understand. Again, an important thing which we can draw from here. That is the most important part.
okay.
Yeah. So fifth and sixth you can do now. Seventh also you can do without any problem. Uh, I would go with problem ninth directly. This is an important part and a little tricky as well. Let's
All right.
do it because it has four vectors in it and we need to figure it out that how four vectors at once can be used and solved.
Okay.
I am heading towards problem number 9.
Yes.
And the problem number 9 says we have to find D minus C plus B minus E. So these are the four vectors. And we will figure it out that how these four vectors are written. And then we'll try to draw them and then we'll be solving them. So D is, it already mentioned, it is 100 kilometers at north 10 degrees of west. Then C. C is given as again 80 kilometers at west 30 degrees of north. But here we have to find minus C. So we'll directly substitute the values of negative C. So negative C, we already find it in the previous question also. So it is going to be, all right, C is not this one. I
Oh,
need a little change. C is the direction of C. Wrong. It is direction of negative C. So C is given as east 30 degrees at south. So whenever I'm
okay.
writing minus C, it will become 80 kilometers at, so east 30 degrees south. What is the reverse direction of this particular vector? Tell me.
It'll be west 30 degrees north.
Hmm. Similarly, we have B vector, which is supposed to be 40 kilometers at north 10 degrees, east 10 degrees north. Then we have E vector. So E vector is given as 10 kilometers at south 40 degrees west. But what we have to find? We have to find negative E because here it is negative. So negative E is going to be, tell me the direction. What is
Um, North 40 degrees east.
correct? So here we got four vectors that we actually need to add. First, second, third, and fourth. So what we can do is we can find out the x and y component of these two vectors directly now. And let's see how it goes. For D, so for D, I'm writing dx directly. So just tell me one thing. The theta that is of 10 degrees, it will be with which axis? X-axis or y-axis?
Um, could you repeat that?
I'm asking this
Yeah,
angle 10 degrees, it will be with which axis? With west or with north?
it would
10
be
degrees.
um. Well, it's north, so it starts from north, and then yeah, it'll be at north, leaning towards
Mm,
west, right?
yeah, yeah, that's right. But again, I would say that we should draw the diagram. That will be better for understanding.
Yeah.
North, south, east, east. So here D vector 100 kilometers at north 10 degrees west. So it is going to like lie like that. It is going to be the 10 degrees and it is which D vector. It is 100 kilometers.
Mm.
Next, negative C vector. This is 80 kilometers west, 30 degrees north. So where am I supposed to draw this? Tell me.
Um, For starting from like west, yeah, up to north. 30 degrees at the bottom side, yeah.
Yeah, correct. So it is going to be negative c. I'll be writing negative c here. And the magnitude is given as 80 kilometers. We'll write 80 kilometers here. Now, this B vector, where it is supposed to lie.
Um, so east, start from east side, going up to north, and then 10 degrees, basically 10 degrees from east.
Hmm. But we have to draw this. Sorry. All right. So it is going to be like that.
Yeah.
10 degrees from east. And the magnitude is given as, we'll write B vector here, magnitude is given as 40 kilometers. Now, the fourth vector, negative E. Tell me about
Start
this.
from north side, 40 degrees to the east.
Just think again.
Negative E, right?
Yeah, negative E.
Yes. Starting from north and then goes 40 degrees to east. Yeah, like that. And then the angles inside of those. Yeah.
Correct. So this is the most important part, that how you actually draw the diagram and how you actually look at the vectors. Now we can easily solve them. There is no problem in solving these two vectors, these four vectors. Process is quite simple.
Mm-hmm.
How we are supposed to do this? This 40 kilometers has a component along x-axis as 40 cos 10, right? This negative e has a component along x-axis as 40 negative 40
Sine.
sine 40.
Yeah. Sine.
See, if there is a problem in understanding that how the sine cos came, just let me know, because this is the most important thing. If you are missing it,
No, I
then
think I understand.
all right. Similarly,
Basically,
here we can see,
is it
yeah,
basically closest side to the vector is cosine and the farthest side is sine in like simple terms?
yeah, that's in simple terms. The
Okay.
component along with the theta or along with the angle, it is always cos. The component along opposite to theta, it is always sine.
Okay.
So here
Got it.
also we can see this thing that it is going to be 100 sine 10 for this d vector, and similarly for this minus c vector, it is going to be minus c, that is I would say minus 80 cos 30.
Okay.
So these are the four vectors that will give us e summation of x, summation along x. Similarly, for summation along y, also we'll write the same. So I'm writing it here. Let's make it finally. So E along summation of x vector is going to be, as we say, 40 cos 10 minus 40 sine 40 plus minus 100 sine 10 plus 80 cos 30. That is the tricky thing. You just need to figure it out and just add it. So negative sine 10. Why it is negative? Because it is along negative x-axis. So I'm writing the value as negative 100 sine 10. Then negative c can be written as it is 80. So it will be automatically negative
Maybe
80 cos 30.
okay.
Then we have 40 cos 10. So we'll simply add it 40 cos 10. Then we have 10 sine 40. So 10,
Mm-hmm.
okay, this should be 10 sine 40, not negative sine negative 40. It should be 10.
Okay.
This is 10 now. So we have to write it 10. So it is going to be negative 10 sine 40.
Sine
So
for. Oh yeah. Sine.
10 sine 40 degrees. So we'll substitute the values of each and we'll get the summation along x-axis. So it is going to be, I'm writing the answer directly, it is approximately negative of 40.8 kilometers. That's it.
Okay.
Similarly, let me write what is summation along y because that is important. We haven't written it yet. So it is going to be 100 cos 10 degrees plus 80 sine 30 degrees plus 40 sine 10 degrees plus 10 sine, or I would say 10 cos 40 degrees, not sine.
Okay.
Now, what is this 100 cos 10? 100 cos 10 is dy. What is this 80 sine 30? 80 sine 30 is negative cy. What is this 40 sine 10? 40 sine 10 is 40 sine of 10. It is going to be by. Now 10 cos 40. It is going to be negative ey. So that is something you need to understand first, that what these vectors are. So this is how the components are being written, and this is how we are supposed to find the components. Does this make sense?
Yeah.
All right, let's just substitute the values. And once we substitute the values, we'll get Ey, or summation along y-axis, it is going to be 98.48 plus 40 plus 6.94 plus 7.66, and this EY is going to be 153.0871 kilometers, I would say. So we got the value of EX, we got the value of EY. Now we can find out the value of resultant. So resultant is going to be R is equals to A square plus B square. I will assume it as my B, and whatever EX we found, we'll assume it as A, like negative 40.8. We'll substitute the values here, so we'll get R is going to be negative 40.8 whole square plus 153.08 whole square under roots. So resultant is coming out to be approximately, it is 153 kilometers only. Oh, sorry, 158 kilometers only. This is what resultant vector is going to be. Now the most important part, direction. The direction of resultant is again given by the tan theta, and it is equals to tan theta summation along y-axis over summation along x-axis. So theta is going to be tan inverse summation along y-axis is something 153.08. Summation along x-axis is nothing but 40.8. We'll simply solve it and we'll get theta as 75.1 degrees. So this is going to be the angle. Now, again, this is not an easy thing to do. It requires a lot of calculations. It requires understanding how vectors lies in the plane and all the direction thing. If you are comfortable with it, then only you will be able to do it. Otherwise, it will take a lot of time. It won't be possible.
Yeah.
So as of
Um.
now, we have done 3 problems only.
Could you maybe like write like each steps like in words, maybe like numbered steps?
Like how?
Like number one, you first establish like the vectors. Number two, you graph it to understand where the position is, like that.
All right, we can do it. No issues. So you can write step one,
Mm.
steps to find resultant using component methods. Component method. First step. As you have seen, the first of all, we actually write the vector along with
Right.
its direction. Write vector along with its direction. Second step. Once you have done with the written part, draw the vector in the given Cartesian plane. In the given Cartesian plane. Considering its direction. Without direction, we cannot draw it. Cartesian plane, considering its direction. Second, next step. Once we are done with this vector drawing, then resolve the vector along x and y axis respectively. And here's a bonus tip. I would write component along the direction, along the angle, given angle is cos component. Next, component and opposite to given angle, it is sine component. So that is an important part. So following these three steps, we know that where the vector lies, we know what is the magnitude of vector, what is the direction of vector, and also we have resolved the vector in the given directions, x and y axis. Next step, repeat the same process. Repeat the same process with other given vectors in the question also. So suppose there are one or two or more vectors are there. So we'll repeat the same process with other vectors, like representing the vector in the Cartesian plane, drawing the writing the direction, then giving the components of it. Fifth step,
Okay.
add the vectors separately along x-axis and y-axis respectively. Like how it should be done. So we'll be simply writing, suppose we are writing summation along x-axis. So it is going to be ax plus bx plus cx, whatever number of vectors are there. Similarly, summation along y-axis is going to be ay plus by plus dz, like that.
Okay.
Once we are once we are having the values of summation along x and summation along y vectors, or you can say net vectors along x and y axis, we find resultant using triangle law. The law which we are using in each question is something we call triangle law. So triangle law gives us the resultant, and resultant is something which is equals to a square plus b square plus 2ab cos 90. Why I am writing 90 here? Because summation along x-axis and y-axis, like the vectors along x-axis and y-axis will always be 90. So that's why theta can be taken as 90 degree here. So here we'll get resultant as square root of a square plus b square, like that. Last step, we also have to find out the direction of this resultant. So direction of this resultant is given by calculating angle made by resultant with x-axis. Like, suppose I got the resultant somewhat like that. This is my R. So this resultant must have some angle. So this angle will actually give us the direction. And this thing can be done by simply using tan theta. So tan theta is nothing but summation along y divided by summation along x. And we have to always take mod of it, like the magnitude. So from here, we'll get theta is going to be tan inverse y by x, like that.
Okay.
So this will give us the direction. So this is the whole process which we applied here. So